We define the meaning of Mo programs in terms of substitution. Even when we implement a Mo interpreter using environments, the environments are just a way of implementing what substitution does, and the meanings of programs are based on substitution. And one property that has is that when you instantiate a variable like x with a given value like 5, the meaning of x, the value associated with x, cannot change afterwards. So in this case, there's a function f that refers to x. This x we know will always be 5, no matter what happens in the dots in between here. Because the meaning of let is we substitute to replace all the x's with 5. So we think of these two programs as equivalent. But not all languages are like this. In some languages, there's a notion of variable, and the variable's value can change. So Java is an example that I'll refer to later, but in fact, Shplait has this property when you define variables in a certain way. There's a mutable modifier that you can use with def. You should not use mutable, not yet, not in any of your interpreters or assignments, but you can declare a variable to be mutable, and then there's something different about this x, because here I am able to use this colon equal operator to change the value associated with x, and when I call the function after that assignment, this x's value will be 100 instead of 0. We would say that this variable x, it has a state. Its current state is 0 or 100 or something else. And in some languages, it's much more common to use state than in Shplait. For example, Java. Here's a typical way to add up a list of numbers in Java. So we iterate over the integers in that list, and each time we change this local variable t to add into it, and then at the end we return t. Now again, in contrast, in Shplait, we would write this without state. We would write a sum function as a recursive function. It just returns 0 in the empty list case, and it recurs to add the first number to the rest in the non-empty case. So there's no t variable written down here anywhere. And therefore, state is not essential to the problem of summing up a list. Now, these two implementations of sum are a little bit different. The Shplait one adds up left to right instead of right to left. We could make them even more the same, still without using state, by adding a t variable to our sum function as an accumulator, so that in the empty case we return t, just like the Java code did at the end, and meanwhile when we get each first item, we add it to the t, left to right, and pass it into the next call. So t is being instantiated each time we call with a different value. We're not changing the variable, it's a different variable each time you call, but it's even more like this Java code, and it has the same space complexity and the same order of addition. So again, it's not essential even if you want to sum from left to right to use state. In Shplait, we might even use full del to implement this, but that's just another way that doesn't use state that adds up the list of numbers. Another example, their state is not essential. In Java, if you wanted to represent an aquarium as an array of integers and then feed the aquarium by increasing each fish's weight, then probably you would just modify that same array to increase the numbers. Whereas in Shplait, we would use a list of integers and we would map addition over that list of integers to get back a new aquarium. So again, if the problem is representing an aquarium and being able to feed all the fish in the aquarium, state might be used in some languages, but it's not essential to the problem. And in fact, avoiding state has some benefits. When we check this feed function that we just wrote, we just pass it a list and we get a new list back, and we write this test case in a straightforward way that compares the results to some other list. We don't have to set up an array and modify the array and then check how the array was modified. Another advantage is if we represent the aquarium today as a list and feed it to get the aquarium of tomorrow, we still have the aquarium of today, and we can compare those two aquariums. The aquarium of today is not destroyed, producing the aquarium of tomorrow. So there's reasons to avoid state, and state is not essential for most problems, but there are some cases where state does seem essential. And a typical example is when you have a GUI library that lets you create some labels, that lets you create buttons, and when I click this button, it's supposed to change this label to say 8 if I click feed 1, or if I click feed 3, it should change it to say 10 instead of 7, and so on. The way that these GUI libraries are set up often is that you need some representation of the current state of the GUI, like a weight that starts out at 0 or 7. And then when you have a button, when you create the button, you provide a callback function that probably changes some variable, changes some state, that corresponds to the weight that's behind this GUI, and then updates the GUI with that. So what's going on here is that the GUI library is expecting us to communicate from buttons to labels using some variable as a side channel, or some amount of state as a side channel. And that is how we can characterize state and its value in general. It offers a side channel for communicating from one part of a program to another. That is, we can have a function call f of 1 affect what a later function call g of 2 is going to do, even though no result from f1 is passed into this call to g. Right? So it's a side channel in that sense. There's something behind the scenes, something to the side of what you see in this control flow that is allowing the communication between those. And this is a good feature of state in many cases. It means you can add whatever new side channels that you need to communicate between two different parts of the program. On the other hand, that benefit is also the drawback, because when you look at this program with f of 1 and g2, the side channels that might be there are not apparent. You have to go read all the code of g and f to see if they communicate. So state has its role, but it also has its drawbacks. In any case, state is an important part of many programming languages, so it's something we should look at in our study of languages here.